The following example is a Mohr circle example that presents to you how we can work out how much to rotate an element by to reach the principal stresses. If you have the ability to understand this example, then you have a very well understanding of the Mohr circle. So if we look at this element, we need to draw the Mohr circle to calculate principal stresses, maximum shear stresses, and the orientation of the planes experiencing the principal stresses. Okay, so we're given this element right here. On this face we have 100 as our x normal stress and minus 40 as the shear stress because it's causing a clockwise moment. So I'm going to use this point and this point. This is how I always do it, and I find it the simplest. Okay, so this point is 100 minus 40, and here we have a negative y normal stress of minus 80 and a positive shear stress anti-clockwise of 40. And now to keep consistent, I'm going to choose this shear stress over here, the minus 40, and use it in every equation because it works out properly. And you'll see by logic that it doesn't matter which one you choose, just like in the previous example. Now, recalling from the previous lecture, or previous 2 lectures or 3 lectures ago, I showed you that we have to differentiate the normal stress in terms of x to work out the principal stresses, the plane of the principal stress, and we can get it in terms of tan, cos, or sine. Now I'm going to show you mathematically that we can use any of these, particularly tan because it's the easiest. We can use tan to work out how much we need to rotate an element by to reach the principal stress. Okay, so I'm just going to use this equation here. So going back mathematically, applying this equation, okay, so this equation is actually positive xy, excuse me, this should be a positive.